How are you today? Is it hard? Two variable calculus? But everything is hard before it easy. This is a quote by German writer and public figure Johann Wolfgang Goethe. Everything is hard before it easy. So it will become easy very soon. First, let's, if you have any questions, because today's topic, and also, we have today quiz, and quiz will be in the subject of two variable calculus, partial derivatives, function of two variables. And today's topic also it's related, very close. And today we will discuss about maximum and minimum of function of two variables. So if you have any questions from homework, you can ask now. Then I will start lecture about maximum and minimum of function of two variables. And next we will take quiz. If any questions, please from homework, if something is unclear, ask me now.
I have a question. It's number 16.
Okay, just a minute. I will open now.
Okay.
I will open just a minute. So derivatives and okay, Mariam, what is your question? Say number again.
I was Katie. It's 16.
Oh, Katie, sorry.
It's okay.
What is your question, Katie?
Number 16.
Number 16, okay. Okay, very good question. Very good question. Okay.
Hello.
Hello. So we have function of two variables f x y equals x square minus y square over 1 plus x square. And we need to find partial derivative fx. And let's find partial derivative, and then to substitute x and y, then it's very easy. Okay, so since we want to find partial derivative for x, y here, we assume that y is constant. But we have here variable in the numerator and in the denominator. That's why here we need formula for quotient of derivative. Let's recall this formula. It's g square in the denominator, derivative of f times g minus f times derivative of g. I hope you remember this formula for variable for function of one variable, and so we should use this formula. Now here in this our case, what is in the numerator? It's f. And what is in the denominator? It's g. Please don't confuse this f with this f. Okay, I can replace here this f by L by function L to not confuse. So now in the formula we have f derivative of f times g. And what is derivative of f? Derivative of f here is 2x. That's all. Because there also we have negative y square, but we assume that y square it's constant, and that's why derivative of y square is 0. So let's continue. Multiply by g. G we have 1 plus x square. Then we have in the formula minus, and here also I will write down minus. Okay. Just a minute, I will correct it. Okay. Next, here we have f. I will write down here f. X square minus y square. Then multiply by derivative of g. And derivative of g. G is 1 plus x square. And what is derivative of 1 plus x square? It's going to be 2x. And finally, I should take square of denominator. 1 plus x square square. Do you agree? Look very critically. Maybe I made some mistakes. Katie, do you agree?
Yes, thank you.
Okay. And now I believe you can continue it. We can then simplify it, but also without simplification, we can just replace x and y by correspondence values. Okay. Now, as I told, today our topic is local maximum and local minimum for function of two variables. And to discuss function of two variables, let's recall what is maximum, local maximum and local minimum in case of function of one variable. In function of one variable, I will draw and I will explain. First of all, I will explain geometrically what it means. If we have function like this, here, this is the local maximum, local minimum, local maximum, and also it's local minimum, this point. So I think geometrically it's easy to explain. And as for how to explain it and how to give definition for local maximum, and we can say that FC is local maximum if there exists near this point C. This point C, I mean, for example, this is point C, and if there near point C there exists some region, some interval And I mean in this case, for example, this interval, and at this interval, uh, fx is less or equal than fc. This is definition. Similarly, in case of two variable, we can say that if AB is maximum if just a minute, I want to use the same denotions as in this book. Oh, yes, they are AB also. So, FAB is maximum if near this point AB, and you know AB is point on the plane, there exists fxy, and this fxy is less or equal fab. And absolutely similarly, also we can define a local minimum. And in the local minimum, this inequality will be replaced by more or equal. So this is FAB, it's a local maximum, and if FAB is a local minimum, in this case, fxy is greater or equal than FAB. Okay. Now most important question, how to find local extremum and local maximum. And it's very important because we know it's related with many real world problems. And as you remember, in case of function of one variable, there we had a necessary condition for point FC to be local maximum or local minimum, and both maximum and minimum they called extremum. And also let's also recall that plural of maximum it's maxima, plural of minimum it's minima, and plural of extremum it's extrema. So in case of single variable, one variable, we had necessary condition that derivative of function at the point C must be equal 0. But it's not sufficient. What means necessary and sufficient? Who take course of discrete mathematics, they know. Who does not, I can explain simply. For example, to be a man, it's necessary to be human being, but it's not sufficient because human being may also be a woman. So, but I can say to be a human being, it's necessary and sufficient to be a man or a woman. So this condition is necessary but not sufficient. It means that when derivative of function equals 0, it's not necessarily means that we definitely know that we have local maximum or local minimum. But when we have local minimum or local maximum, we definitely know that derivative at this point is equals 0. So very good. Now as for so this is when we have function of single variable or function of one variable. In case of two variable, we have also necessary condition, and this necessary condition is that both partial derivatives so let's have a function f x y and f a b local extremum. Local extremum, we know it's a local maximum or local minimum. So in this case, from this that FIB is local extremum, it implies that both partial derivatives fxab equals 0 and fyab also equals 0. So it's in fact its implication and one-side implication, not by implication. So this FAB is local extremum. It implies that both partial derivatives equal 0, but not the reverse. From this, that these partial derivatives equal 0 does not imply that FAB necessarily is local extremum. Okay. Any questions so far? Okay. Now more important thing. When given a function, how can we find extremum of this function? Most important thing and most important application of derivatives. How to find maximum, how to find minimum. So first of all, we need to find both partial derivatives. And we should find point and this point AB point, it's ordered pair. Point I mean in the plane ordered pair, it's point, it's geometrical interpretation of ordered pair. So it's critical point. Next step is that we need to find all second order derivatives. Second order partial derivatives. And next step, we should find, let's denote by A, f x x a b let's b equals, it's just the notion, f xy also AB here, and let's CB and let's CB F AB YY. Okay, and now we will now construct very important its number, in fact its number, and it's A times C minus B square. We should find this number, A times C minus B square. Now let's denote it by D. Now, if D less than 0, if D is negative, so problem, you can finish your problem, because when D is less than 0, it means that we have no local maximum. We have no local extremum. We have no local extremum. It means we have no local maximum and no local minimum. If D equals 0, it means we can't determine this point is point of local maximum or point of local minimum. So also in this case, our problem finished. You can write down answer. Test failed. There are no local, we don't know, is there local minimum or local maximum? Okay. So in this case, test fails, this test. And finally, when our number D is positive, in this case, we have local extremum. But now we should determine this local maximum is, this local extremum is a local maximum or local minimum. And it depends from the A. As you remember, by A, we denoted second order derivative by x. So it depends from the A, and let's recall also here F and if it's negative, it means FAB is a local maximum. If A is positive, if A is positive, it means that F AB its point of local minimum. Let's start by example, and it will be more clear. For example, we have a function z equals x square plus y square plus 2. And we need to find local minimum or local maximum if they exist. So first step is to find first derivative. And what is first derivative? First derivative f(x) equals, please help me, what is first derivative by x?
2x plus 2y.
No,
Just 2x.
2x.
Just 2x.
Just 2x, because in this case, y square plus 2, they are constants. So in this case, it's 2x. Okay, now I should find when this first derivative is equal to 0. So I should solve equation 2x equals 0, and from here x equals 0. Okay. Next step is to find derivative by y. And what is it? Any idea?
Just 2y.
Yes, in this case, x squared plus 2, it's constant. So we have here 2y. And we will do in the same way, 2y equals 0 and y equals 0. Okay, so it was first step. What we have now found? We have just found critical point. We don't know this, so we found that point 0, 0, it's critical point. Critical point. But we don't know f(0, 0), f(0, 0), it's local maximum or local minimum. We don't know yet. But we will try to determine it and to determine, and we should continue our research about this critical point. And how? Let's follow our steps. I will show it again. Yes. So this is our steps. We need to find, first of all, we need to find this number. A times C plus B square. And to find it, A times C minus B square, we should find all second derivatives. So first of all, let's find f(x)(x). What is f(x)(x)?
Just
f(x)(x), it's 2 times x, 2 times x, and derivative by x. Absolutely, it's 2. Very good. Okay, what's f(x)(y)?
It will be
fxy
0.
absolutely.
yeah 2 minus 2.
It's 2x derivative by y, and absolutely right. It's 2 because 2x it's constant because we need to find derivative by y. Okay, and the last. So how we denoted it? We denoted it, this is A, this is B, and now I will find C. So f y it's 2y derivative y, and it's 2 again. Okay, now we need to find point D, and this not point, sorry, but number D, and this D it's A times C minus B squared. Okay, and now what we have? So it's C. It's C. So what is A times C minus B squared? It's very easy to calculate. It's 2 times 2 minus 0 squared. So it's 4. But this number 4, it does not matter. It's 4 or 100 on 1 billion. What does matter? It's sign, and sign it's 0. It's positive. So since positive, now let's look when A is positive, it means this is local minimum. So what can we conclude? We can conclude that if we remember our critical point, it was 0, 0, and we can make conclusion that f0, 0, it's local minimum. Now, if we want to find this local minimum, any idea of how can we find this local minimum? We need just to replace x and y by zeros in our original function. So it's going to be 0, 0 square plus 0 square plus 4. 4 or 2, what we have here?
2, 2.
Plus 2. It equals 2. So we found local minimum. This function has one local minimum, and this local minimum is 2. So you can test it, and you can replace x and y by any numbers, and you can get result less than 2. Okay. Now I want to start by next example. It's more interesting, but if you have any questions, please ask now. Next function is so given now function and we need to find local extrema. Local extrema. Function may have one local extrema or more. So we will follow our algorithm, and first is to find first order partial derivatives. Help me please. What's partial derivative? Minus 2x. Derivative
plus
of
6.
Derivative of y square is 0 because
Zero.
y is constant and hence y square is constant. Minus 2x plus 6 and another part 8 times y minus 21, it's constant.
0.
It's constant, yes, and that's why derivative is 0. Okay, very good. Okay, now let's equate it to 0. And from here, x equals 3. Okay, as for another partial derivative, y xy is going to be derivative of minus x square. It's 0.
Minus 2.
No. Derivative of minus x square. Yes, minus 2y. Absolutely. So here we have minus 2 times y and plus 8 because derivative of 6x minus 21 is 0. So minus 2 times y plus 8. Okay, now let's equate it to 0. Minus 2y plus 8 equals 0, and from here y equals 4. Okay, so now what we know definitely, we know that this ordered pair, or we can say point with coordinates 3, 4, it's critical point. And this is only critical point. There are no other critical points. It's critical point. Critical point. Okay. Now what is next step? Next step is to find now number D, very important number. And to find this number, we need second order partial derivatives. And these second order partial derivatives, let's fxx, xy equals, okay, let's recall what is first order partial derivative by x. It's, do you remember? I hope you are writing down this. Okay, I will show. It's minus 2x plus 6. And we need to find this derivative of 4x. It's clear, it's 2. Okay, so it means that A equals
But it's not a -2 because
yes.
we have like one.
Okay. Yes. Thank you. I made mistake here. Thank you. Here we had -2. -2x plus 6, it's -2. So we have a equals -2. Okay. Now next is to find b. B it's fxy fxy, and it's going to be any idea?
It's gonna be 0 and like the y equals to -2.
Right, it's 0. So b equals 0. And finally, f y, it's, oh, here I made mistake again. Here should be minus, but it can't affect on the result. So f y, it's minus 2 times y plus 8, and it's -2 again. Do you agree?
Yes.
Okay. Now let's find very important number d, and let's rewrite again. What is d? D is a times c minus b squared.
It's 4.
A times c minus b squared, and it's -2 times -2 and -0 squared. And we got 4, and 4 is positive. What does matter for us? Okay. And we got that our function has maximum. This maximum is f(3,4). And to find this maximum, we need to replace x by 3 and 4, y by 4 in the original function. So we need to find
Maximum or minimum? Is it local minimum or like local maximum?
Okay, very good question. So I missed one step, and thanks for this note. So we got d is positive. Now what it means? Let's look back to our algorithm, our general algorithm. So we got d is positive. D is positive. It means that we know definitely this function has a local extremum. We don't know yet. This is a local maximum or local minimum. But to find its local maximum or local minimum, we should look to the sign of a. A is second order partial derivative by x. And when a is positive, this is the local minimum, and when a Look, first case, when A is local minimum, then FAB is a local maximum. Now, in this our case, what is A? Let's look what is
Minus
A. A is minus
less 0.
A is minus 2. It's less than 0. Less than 0.
Means that it's local maximum.
It's local maximum. But here I missed one step. And I should write here A. And A it's F X X 3, 4. It's I will write down it's negative. It does not matter what is this exact value. What does matter?
Less than 0.
It's less than 0. We know it's negative 4, but I wrote only it's less than 0. You can write that it equals minus 4. Okay, so now I know definitely that this is F3, 4. It's a local maximum. And now I think it's easy for you to find it. F34. And what is this value of F34? Okay, any questions so far?
It's 18, I think.
Okay, very good, thank you. Could you please confirm that it's 18? 18 or 80? 1, 8.
1, 8, 18.
1, 8.
Yes.
So, hope it's not hard, but if it's hard, recall that everything is hard before it is easy. So, now if you want, you can take a break and you can give again questions about partial derivatives, and I will send you our quiz problems.
Sorry, it is 22. I had like...
Okay, thank you. 22. Okay, and so if you want to take break, you can take break, but if you feel fresh, I can send our quiz materials right now and you can start. And if you feel that you are tired, you can rest during your quiz.
I think it's better to send now. So
Okay,
we can...
I will send right now. Just
Yeah.
Just a minute. But before start, now you can I need just 1 minute to convert it in the PDF format.
I'm sorry, I can't find.
I did not send it, Saddam.
Okay.
I'm sending now.
Sorry, I just have a question. Just one question.
Okay.
I just had problems with like 50 exercise. Exercise number 50.
Okay, just a minute.
Okay.
Just a minute, Idris. I have just sent it and try to find it. And okay, 50. Idris, 50, 50.
Yeah.
Okay. Okay, very good question. Let's answer Idris. Okay, so we have a function s x y x cube ln y plus 4 times y square e to power x. Okay, please be very careful. And we need to find s, x, y. Okay, so first of all, we need to find first order partial derivative. First order partial derivative. And first order partial derivative, let's denote s sub x, x, y. Okay, what is derivative of x cube ln y? Who has great idea?
It will be 3x square.
What?
3x square.
Not really.
3x square ln y.
Oh, yeah.
X square times ln y. Yes, I agree with Georgi. So because let's give example of, for instance, 5 times x cube. 5 is constant. We will move out 5 and derivative will be 5 times 3x square. And the same we have here. ln y is constant. We can move out it and our result will be 3 times ln y times x square. I will take in the parentheses to not confuse and to be more clear. Okay, as for derivative of 4 times y square e to power x. I recommend to all of you that look very careful to this our explanation, because quiz problems are close with this problem. So here, what is constant? 4 times y square. And I know very well, and e to power x derivative is e to power x again. So we have here 4 times y square e to power x. Okay, now what we need now to find second order derivative sxy, and it's going to be its derivative of first order derivative by x. So it's going to be 3x square. Let's first write down x square to be more clear visualization, and ln y plus 4 times e to power x, or it does not matter, I can write down 4 times y square e to power x, and I should take this derivative by y. And it's going to be, now 3x square is constant. X square is constant, and derivative of ln y, it's 1 over y plus, here 4 times e to power x, it's constant. So we have 4 times e to power x multiply.
Sorry, why is it? Yes, like can't you write like 8y e to power x?
Yes.
Actually, yes. Yeah.
It's 8 when we will multiply.
Yes. Wait.
4 by 2, of course it's 8. But I prefer to write down in details.
Sure.
So now you can rewrite it, and I can correct here. I have this opportunity, and I will write here that it's 8 times y square e to power x. And this is a final answer. And also I don't need this parenthesis.
Okay. Thank you very much.
Thanks for question. So now you can start our quiz.